Hello, we're going to look at the law of large numbers now. Uh, and in the law of large numbers, we have to know the difference between x bar and mu. X bar is an approximate for the true population of the mean mu. If we increase the size of our sample, we should get closer and closer to mu. That's the big idea of this law of large numbers. Now let's see what that means. Let's say we have a huge population, maybe the height of everybody at Irondale. We could go to each of the 1700 students and find their height and then take the mean average, the average of everybody, and we could get a distribution like this, and the average of everybody would be there. But we could also take a sample and maybe of 15 kids, and the mean of that sample will be x bar. Now, we would expect our sample, x bar, to be very close to mu. But it's going to deviate from sample to sample. If we sample another group of kids, our x bar will be different. But the law of large numbers says if we draw independent observations at random from a population with a finite mean, mu, first we have to decide how accurately we want to estimate mu. As the number of observations increase, the mean x bar of the observed values eventually approaches the mean mu for the population as you specified. So here's a graph. Say you're taking a sample mean where the true mean is 64.5. If we take one sample, it might be a little below. Up to 3 samples, our mean is still below. And then once we get up to 4 samples, it was higher. And you can see it just keeps on going back and forth. But as our n gets up to 10,000 observations, you can see it gets closer and closer to the true sample mean. And if you right down here, I say, what's wrong with this graph? And if you look at this graph, you'll think that's a pretty weird increase. It goes from 1 to 10 to 100 to 1,000 to 10,000. This isn't necessarily wrong. What it is they're using a log scale. So if we log each of these values, it would be 0, 1, 2, 3, 4, and those numbers are evenly spaced. But the log scale allows us to go from a small amount to a large amount and see the variation in there. Now, there's a lot of small numbers in quotes because it's not actually a lot. It's just something that humans do, and they think that they know something. For instance, hot streaks in basketball or hitting streaks in baseball. When you're doing a small sample, say 5 hits in a baseball game, sometimes it's just by random chance you'll hit 4 out of 5 of those baseballs, even though your average is really 30%, batting 300. So sometimes you do go on streaks, not because the player is doing bad, just because that's the nature of random variables. Our intuition is generally not reliable from distinguishing random events from systematic patterns. And this is where we need statistical tools to help us with that. So if we wanted to find the average height of women between 18 and 24, we could take an SRS of those women. The mean height of these women would be x bar. If we took another sample of 200, would we get the same result? Hopefully you say no. It might be a little higher, might be a little lower. There's gonna be variation. And a lot of this class from here on out is to figure out what kind of variation is acceptable. All right, well, now we'll go on to the next video.